Today we'll be looking at measuring instruments used to measure in physics. So here I have my meter rule. It's from 0 to 100 centimeter graduation. Here I have my vernier caliper. This is a digital vernier caliper, as you can see. Once you put it on and you fix it with any apparatus, it reads on its own. Here we have a micrometer screw gauge. And this is our manual vernier caliper here, and of course this is our triple beam balance here. It has 3 layers on its own and is used to look for calculate or read the mass of any object. Okay, on top of it I have my beaker. It's empty though, empty beaker. So after much adjustment of all the 3 layers, there's a point here you have your balance point, which reads what this mass is, what's the value of this mass. So at the back here is from 0 to 100 grams, here is from 0 to 500, here is from 0 to 10. So looking at the last part, is between 60 and 70, that means I have 65 grams. The one at the middle is 100 grams, and the one here is just 1 gram. So adding it up gives us the value of this empty beaker. So that means we have 6500, that's 165, plus 1, that's 166. So approximately thereabouts, the value of the mass of this beaker is around 166 grams. So that's what the beam balance is actually used for. It's a triple beam balance, being that it has 3 layers, 3 for triple. So the micrometers, the vernier caliper is used to mostly measure inner and outer diameter of any object. An object that looks like this is a concentric circle, has 2 circles embedded in one another. So the smaller part, the upper part, is used to measure the inner diameter. So you just draw it out and you record what the value of the inner diameter is. You find that value, then the one below is used to record what the outer diameter is. So finding the difference, this is graduated in millimeters anyway, so finding the difference gives you the value of the diameter for this circle. Like I said, it's only applicable to concentric circles. That's a place where you have 2 circles embedded in one, like an open pipe here, where you have pipes here. And you can also use the digital, to calculate it. The digital gives this is the digital here. Then for your micrometer screw gauge, is used to calculate the diameter of small tiny objects like this that you cannot normally get on your meter rule. So you just fix it in. Okay. Okay. So you fix it in and use to calculate the diameter. So here it has 2 sets of scales. It has the main scale and it has the second scale. So the main scale here is reading a little past 0. So that means that's my 0 point. It's not up to 1. The main scale is not up to 1. But for this second scale is between 27 to 30. And the second scale is usually 0 point. So if you have 30 here, that means it's 0.30. If you have 40, 0.40. So if the main scale is, if it is reading 1, for example, that means you have 1.30. It's an addition. So the main scale is whole numbered. The other scale is decimal, in 2 decimal places most times. So here, you can look at here that the main scale here is reading 0.1234, 0.4. That's what the main scale here is reading, 0.4. Is not up to 1 millimeters. And the second scale here is actually on 29, so that means 0.29. So you have your 0.4 plus 0.29. So that means the diameter of this is actually 0.69, adding it up in millimeters, adding it up together. Okay, so, and you can also use the same for your simple pendulum bulb. It's also useful for the simple pendulum bulb. So let's look at simple pendulum bulb, which obviously has a wider diameter. Okay, So fixing it in, I have the value of the diameter for my simple pendulum bulb. And looking at it here, okay, so for my main scale now is a little above 20. My main scale, that's around 21, and my other scale is on 45. So that means I have 20 millimeters, then 0.45 millimeters. Adding it up, I have 20.45 millimeters for my simple pendulum bulb. Then the meter rule, okay, I can also use to get the value of the length of this little rod here. Looking at it, I have a 10.5 centimeter. The meter